All right, ladies and gentlemen, let's move on to example 7. Last one for 9.2. We're talking about a conditional probability. So at a school, 60% of students buy a school lunch, only 10% of the students buy a lunch and dessert. So what is the probability a student buys a lunch also buys dessert? What we find is if we solve for the probability of B of the condition of B after A. That's this guy here. Let me highlight it. B after A. Remember, that's this part of the equation. Now, according to math, anytime we have multiplication, if we want to solve for something, we want to isolate it and say what it's equal to, and we have multiplication, we just divide. And we divide by what we want to move. I want the probability of B after A to stay on its own because I want to be able to calculate B after A because that's what it's saying. What is the probability that a student who buys a lunch also buys dessert? And that's the probability of B after A. So that means I want to move the probability of A. And what I do to one side, I have to do to the other. So what we're seeing here is by using algebra, we can actually solve that equation that helps us define independent events to find a conditional probability of B after A. Because probability of B after A is the probability of A and B, which we have, that's 10%, divided by the probability of A, which we have, it's 60%. So I already had those numbers kind of written out here. We have the probability of A and B is 10%, and we have, we have that over here as well. We have the probability of A, which is 60% or 0.6. I can actually take those numbers as 0.1 and 0.6, and that's going to be the same thing if we were looking at this as just 1 divided by 6. And 1 divided by 6 is approximately 0.167 or 16.7%. So the probability that a student buys lunch, also buys dessert is 16.7%.